Okay, so I hope everyone is back. Let me share my screen again. Okay, so uh, we have discussed about the BOD, your BOD formula, right? So we will have to do some numericals related to BOD. So this is one of the numericals you can see. A numerical related to your DO concentration and also the BOD to find out the BOD. Okay. So the question is like if 2.5 ml of raw sewage has been diluted to 250 milliliter and DO concentration of the diluted sample at the beginning of the BOD test was 8 milligram per liter and 5 milligram per liter after 5-day incubation at 20 degrees Celsius, find the BOD of the raw sewage. That means here, first of all, 2.5 liter of raw sewage, it has been diluted to 250 milliliter. Okay, and here the DO concentration of the diluted sample, it is at the beginning of the BOD test, that is, it was like 8 milligram per liter, and after the BOD test has been conducted for 5 days at 20 degrees Celsius, the DO concentration of that sample is now 5 milligram per liter. Okay. Now the question is that you have to find the BOD of the raw sewage. Okay. So now you can write down the given part, that is your what is the volume of the sample of sewage. At first it was 2.5 milliliter. Then again the volume of the diluted sample, that is your 250 milliliter given in the question itself. Then you can find out the dilution ratio. Okay, we have learned about the diluted factor just now. Okay, that is your volume of the diluted sample divided by volume of the sample of the sewage, or the volume of the undiluted sample. That is, if you divide both 250 divided by 2.5, then you will be getting 100. Okay, so this is your dilution ratio formula, that is your volume of diluted sample divided by volume of undiluted sample, that you will get 100. Okay, if you divide both, then after getting the dilution ratio, you can simply put it in the, you have to put it in the BOD formula, that is your formula was your like this one, loss of oxygen multiplied by dilution factor. But now you don't have the loss of oxygen value. Okay, so how to find out the loss of dissolved oxygen? That is one formula, that is like you have to subtract the DO before the testing and the DO content after the testing. That is, the DO you have got before testing is 8 milligram per liter. Okay, and after 5 day this one doing the test, after 5 day at 20 degrees Celsius, you are getting it to be 5 milligram per liter. So you just subtract both and you will get 3 milligram per liter of your loss of oxygen. So now you just put it in the formula. It's very simple. BOD of sewage is equal to your loss of oxygen multiplied by dilution factor. So after multiplying both, you will get to be 300 milligram per liter. Okay, I hope this numerical is clear to you. Not that tough. Okay, similar kind of numerical is again there. This one is a kind of a similar numerical, but the question is a little bit of different. So that is, here it is given as like a 2% solution of a sewage sample is incubated for 5 days at 20 degrees Celsius. The depletion of oxygen was found to be 4 ppm. Determine the BOD of the sewage. So here your what is the percent of solution given to you? It is 2%. So you have to find out the dilution factor. So in fact, in case of like this kind of questions, when your percentage is given to you, okay, and not the, suppose it is not given as your volume of diluted sample or volume of undiluted sample is not given to you, and only a percent is given to you. So that means, okay, so that means you have to just divide the percentage of solution, by 100. So it will be 100 divided by your whatever percent is given to you. So if it is 3%, then you write it to be 100 by 3, or if it is 4%, then 100 by 4. And now here it is given as 2%, so it will be 100 by 2. So you are getting it to be 50. So the dilution factor, you are getting it to be 50. So depletion of oxygen is 4 ppm. Depletion of oxygen means your loss of oxygen. Okay, directly you are being given the value, loss of oxygen, dissolved oxygen value is 4 ppm. Okay, so the depletion of oxygen value you have, dilution factor value you have. So now you can automatically find out the BOD of the sewage, which is the formula is your loss of oxygen multiplied by dilution factor, isn't it? So here you just multiply it, you will get 4 into 50, so 200 ppm is your BOD of the sewage. Okay, so these two numericals are very simple. I hope this numerical is, both the numericals are clear to you. Okay, next we have two terminologies, that is your population equivalent and one is your relative stability. Okay, so this population equivalent, okay, it gives you, like the strength of the industrial wastewater. Okay, it gives you the strength of the industrial wastewater for, the estimation, like how much treatment is required at the uh, treatment plant. Okay, so it gives you basically the strength of the industrial wastewater. And it helps in giving the realistic charge, like how it is basically the charge for the industries. It is generally not taken by the volume of the sewage. Okay, but it is to be charged from the industries, like what is the strength of the industrial wastewater. In the case of that, the industries should be, it should be charged. So this population equivalent, it basically helps in like assessing what is the realistic charge for this treatment required for the industries. Okay, but instead of taking the charge by the volume of the sewage. Okay, so that is basically your population equivalent. Then we have a, a certain formula for your population equivalent, that is your standard BOD of the industrial sewage is equal to standard BOD of domestic sewage per person per day multiplied by your population equivalent. Okay, and basically the industrial wastewaters, these are basically compared with the per capita normal domestic wastewaters. Like per capita means it is per person. So how like it is compared with the how much a person they are using the domestic wastewater to the industry charge. Okay, to the charge, the industries are being charged for how much pollution it is caused by them on the basis of the strength of the wastewaters they are disposing of. So this is the formula for your standard BOD of the industrial sewage, that is your standard BOD of domestic sewage per person per day multiplied by your population equivalent. So basically the average standard BOD of the domestic sewage is already been worked out as your 0.08 kg per day per person. So from this, this 0.08, it's been already been worked out for the average standard BOD of the domestic sewage. So if you have to find out the BOD of the sewage, like coming from the industries, so for the 300 kg per day, then you have to just put it in the formula like BOD of the industry in kg per day divided by the 0.08 kg per day per person is the formula for your population equivalent. You just put the what is the BOD that is coming from the industry in kg per day. If it is 300, then you just put it 300 divided by your 0.08. 0.08 basically it is the fixed value that it is in the formula. Okay. Next, the similar terminology is there. It is about relative stability. So what is a relative stability? It is the relative stability of which is generally of a treated sewage. Okay. It gives you the ratio of the oxygen. It gives you the ratio of the oxygen that is available in the influent. Okay, that is your that is occurring as DO of your nitrite or nitrate to the total oxygen required to satisfy its first stage BOD demand. If you can remember the first stage BOD demand, actually in the next class, I will be showing you the first stage BOD demand. I think you can remember the first stage expression, the expression for the first stage BOD. So here basically it is the ratio of your oxygen available in the effluent to the total oxygen required to satisfy the first stage BOD. So it has a formula like S is equal to 100, 1 minus 0.794 T20. So if here one is at your 20 degrees Celsius and another one is at your 37 degrees Celsius. So 1S is equal to 100, 1 minus 0.794 T to the power 20 and one is like 0.630 to the power 3, T at 37 degree Celsius. So this T20 and T37, these both represent the time that is taken in days for a sewage sample to decolorize a standard volume of methylene blue solution when incubated at 20 degrees Celsius or 37 degrees Celsius respectively. So while doing the test or some test, okay, so here, it's generally been used as your methylene blue solution is taken. So the time taken to decolorize this volume of this methylene blue solution, okay, so that is at 20 degree days, at 20 days and at your 37 days. Okay, so this is about your relative stability. Okay. So this is all about your the characteristics of your uh, sewage. Okay, whatever was included in your characteristics of sewage all has been discussed till now. So next we are going to study about the treatment part and also about the sewer pipe also we have to study. Okay, sewers we have to study, sewerage, all these things we have to study about the pipes, that is sewers. So basically that one I will be doing, I think, after your treatment part I will do, okay, because treatment is more important. So I will start off with the treatment of sewage part. Okay, so let me see. Just wait, okay. Okay, so we have now the, I have seen the syllabus, so it is your like the treatment part we have to do. Okay, so since it's a new this one topic, so I don't like to start it today. Okay, so I will start with it with a fresh day. So on Tuesday I will be doing the treatment part. Okay, we have like 1 month remaining for your, I think, for your classes. So we will be finishing it. I think we will finish it off quickly. Okay, so let me start it on the next class, not today. Okay, so up to characteristics, I think, I hope everyone is clear with the sewage characteristics. Okay, if any you have any problem in understanding, you can ask me. Okay, okay, then you give your attendances in the WhatsApp group in 5 minutes. Okay, don't do delay after that. I will not take. Otherwise, I will not accept your attendance. Okay, then you can leave the meeting and give your attendances in the WhatsApp group. Thank you.